Hello my dear students, welcome back to our YouTube channel Diksha Karnataka. I am Ankit Srivastava bringing you day 2 of our 60 out of 60 in KCET mathematics series. I hope you are all doing very good, very positive. I hope you enjoyed the last session and it did work out for you. It helped you in understanding the basics of types of relations, and we also solved questions on types of relations. I hope it was very informative and it did help you to solve any problem apart from these 10 questions that we solved in our previous session. Okay, great sir. Now what is that we have for today's session? Today we're going to continue with the chapter PU2 relation and function. First chapter we are doing, right? Second session of this chapter. In today's session we'll complete the chapter by completing types of function in this chapter. Okay, again we'll do the all concepts, then we'll move on to solve questions on these concepts of types of functions. Okay, so get ready, have the energy with you. If you need to take a break, do that, come back for the session, bring your pen and paper and keep solving questions with me. Alright, let's start with the session. So first thing what we have to do here bacha is let's recall what we learned in the previous class, how it's going to help us in today's class, and also what we need to know the prerequisites for the functions moving on to solve the questions, to understand the concept of this session. Very good sir. Okay, so what did we learn in the previous class? Types of relations. What we learned? Types of relations sir. Okay, remember we learnt about empty relation, we learnt about identity relation, right? Empty relation means sir, no elements in the set, no relations between the elements of the sets of R. What is the identity relation? When the relation exists only between the number and itself from the set. Excellent. We learnt about three most important ones. What were those three? Reflexive, symmetric and transitive. Okay, we learned the relations for reflexive, symmetric and transitive. When can we call a relation to be reflexive? When can we call a relation to be symmetric and transitive? If I have to summarize it, I hope you can recall. I can write this as simply sir ARA. What for symmetric? By ARB, then BRA. What about transitive sir? Same way, ARA and BRC, therefore ARC. Okay, you need to revise. If you're not able to understand this from here, go back, watch the video and revise and then come back for this session. Alright, okay, what is it? Now functions. We are learning this word for the first time? No sir, actually in grade 10 also we used to always have this word in mathematics, functions, right? How we used to represent it? Sir, function in some variable, so function in x, function in some variable y, function in some variable t, whatever it is. So function in the variable x is written as f of x. This can be a linear function sir, x plus 2, quadratic function sir, x square plus 2, okay, and we can keep writing cubic, or we can write it as exponential function, e power x, or logarithmic function. So all different type of functions you have already learnt, their basics, their domain, range, all of you learnt in the PU1 portions. Anyway, when we come up with the PU1 series, which is after the PU2 portions is over, then you will again be able to recall and revise it with me. No problem. Alright sir. So for now, you can just accept it, saying that function notation is f of x in variable x. Chalo, very good. For any function what we will have its domain, we will have its range. Okay sir, we will also have codomain. What is codomain? So if I am writing a function for two non-empty set a to b, okay, a to b, then b will be called what? Codomain. b will be called codomain. Okay, what is a is my domain. Okay, what is the range bacha? Range is all those values of y. I can write this function fx as just y. All those values of y, when we put in some values of x, okay, from the domain, whatever we get for y, that can be my what? Range. That can be my range. Alright sir. Now you might have this question, sir, isn't range and codomain equal in case of function? Because what is the definition of function? There exists only one image for every element in domain. So if I have domain as A and domain as B, then every element in A will have unique image in B. All right, isn't that the definition of function, sir? Yes, it is. But we also have classification in the function, right, bacha? So even some conditions are there where even this is not true, that will also be a function. But what type of function? We will learn, because what's the topic? The topic is types of functions. So we will learn about it right now. So some cases range and domain are not equal. Okay, but for a function you can also take at places that range and domain is range and codomain, right? Not domain, na? Range and codomain are equal. I misspelled. So range and codomain. Chaliye. So I hope you understood. We learned a relation. I recalled what is your functions. Okay, for any non-empty sets A and B, I can write a function like this. Now it can be of different kind, different variety. And what is the required condition? For every element from the domain, it should have unique image in codomain, okay, or in the set B. Chaliye, clear, sir? This part is clear, sir. Moving on to the first type of function. What is it? 1-1 function. 1-1 function. Other name of 1-1 function? Injective function. Other name of 1-1 function is injective function. Okay, so in the question sometime they will mention 1-1 function. Easy, we will remember it. But sometimes in the exams also they mention it as injective, bijective, surjective, forgive me. So you have to remember both the names, bacha. Okay, whether it is 1-1 or injective, remember both the names. Bijective also, whatever it is, we learn about it, but remember all the names, because in this question no, not much calculation will be there. In this chapter calculation is not there, so only definition based question can be asked. Only certain question where application based question is asked, then you will have calculations. We have taken some questions like that also, but today it's very important that we should know all the other names of the function. So when I was a student, let's say I am sitting and watching this video, being a student, I would read 1-1 and move on. No. Okay, you should also know injective function. So okay, what does the function defined as? So a function on A and B. A and B means my domain is A, B is codomain or range, okay, is called 1-1. We will call this function to be 1-1 only if distinct values or distinct element of A has distinct images in B. What does it mean? Check here. What does it mean? Check here. Distinct value. So value A has the image P. As we go to value B, the image is changed to Q. As you go to value C, image is changed to R. Okay, now for S there is no image, that's all right, but for distinct values in element of A has distinct image. This part is satisfied, right? Different value. So basically what I'm trying to say, if I take the element of A to be, let's say, X, if I take X1 not equal to X2, X1, what I've done, okay, we don't need two lines, right? Only one will be enough. X1 not equal to X2, what happens, bacha? If X1 and X2 are different, then their values of the function will also be different, And if you have a case where value of the function at two values are like this, so f of x1 equals to f of x2, if this is true, then only possible if x1 is equal to x2. Okay, so it does not make sense to you right now, sir. Obvious, no? If you're saying the value is same, the function is same, this will be helpful, bacha, to solve problems. Okay, because in the problem when number is not given, functions will be given, right? So you will be able to compare and solve the problems using these definitions. So that's why I've written the definitions here. X1 not equal to x2 means fx1 will not be equal to fx2. Same goes here. If x1 is equal to x2 means fx1 will be equal to fx2, and this is the condition for only 1-1 function, 1-1 function or injective function. I hope this is clear. Same thing is written here. Okay, x1 and x2 belongs where? From the set A. Okay, then what is the element of set B? Because we have talked about only element of set A, x1 and x2 belongs to set A. Then what is the element of set B? These are these values, fx1 and fx2, right? Because what is fx1 means? It means the image of x1, right? fx1 means what, bacha? fx1 means image of x1, which is what? In the B. So these fx1 and fx2 will be present where? In set B. In set B. I hope you can understand that. Okay, chaliye. Now next one is just opposite to what we learned right now, many one. Previous one was saying that every element will be having unique image. Okay, but over here, look. So for B, forgive me, for B, what is my image? Q. But also for D, image is Q. So does the uniqueness still exist? For both B and D, Q is present. So if I have to write again that statement, basically, you can see here, x1 is not equal to x2. Why, sir? Because B and D are not equal. B and D are not equal. But what is fx1 and fx2? fx1 is equal to fx2. fx1 is equal to fx2. So even though the B and D are not equal, the function value at B and D is Q. B and D is Q. Both is equal to Q. So when this is true, we will say what? That the function is many one. The function is many one. Okay? Okay? Definition is there. If you want to read it, let me read it for you. Function from A to B is called many one function only when there exist at least two distinct element, right? Because x1 is not equal to x2. If it is equal means they are not distinct, right? So two distinct element for which images means functions value are same in set B. So Q is the same number. I hope this is clear. Very good, bacha. Okay, so fx1 equals to fx2 equals to Q. Whenever this happens, we will say, so see, in the previous case, when x1 was not equal to x2, fx1 was not equal to fx2. So this is 1, 1 or injective. In case of many one, even though x1 and x2 are not equal, fx1 and fx2 are equal. So many one. Chaliye. Moving on. Now how will you identify the given function is many one or 1, 1? Okay, so there's two methods, bacha. One is graphical method. I love graphical method. Okay, I'll tell you one thing. If you want to excel in mathematics, if you want to be fast in mathematics, try to learn graphs. Okay, get a source and try to learn all the functions graph, even for composite functions. Okay, whether it is there in syllabus or not does not matter. Okay, don't worry about the syllabus portion, because if you know functions, if you know their graphs, their domain, their restricted domain, if you know all of this now, then you will be able to solve any question. Based on those functions. Okay, so graph is my favorite part in mathematics. Make sure that you learn to solve all the graphs. If you need me to, comment below and I will come with a small series where we'll explain you. Or anyway, even the chapter wise when I'm going, no, I will explain you the graph, because I will always give importance to the graphs, because I know being a student it helped me, and I know being you guys the student with me, it will help you as well. So I will always give understanding and emphasis to the graph part. Chaliye. So let's see. So methods to check whether a function is on the set A and B. A is my domain, B is my codomain. 1, 1 or many one. चलिए बताइए, it is 1, 1 or many one. Okay, how will we tell, sir? So there are two methods, method number 1 and method number 2. Okay, method number 2 is the graphical method. Method number 2 is the graphical method. We'll come to that. Right now this I already explained. Okay, so consider any two elements x1 and x2. From where, sir? From the domain. From the domain set we will consider two elements. Okay, and then find this fx1 and fx2. If they are equal, when this is equal, it means 1, 1. I told you right? If they are equal, when these are equal, then they are 1, 1. If not, then many one. If this is equal but this is not equal, then many one. I did it right now. If fx1 equals to fx2 but x1 is not equal to x2, means for distinct element in the domain x1 and x2, function is equal. By many one, right? It is many one. Okay, see, for distinct element in the domain, the function value is same. It means many one. When it is not the same, means then we can say, means same value will give me same thing. So it is 1, 1. Chaliye. I hope this is clear. Okay. If not, go back and see the previous slides. If any straight line, now this is my favorite part. So whatever the function is given, you draw that function. Okay, you draw the function. Let me take a linear function like this. Y equal to x. I've taken a curve y equal to x. So if you draw a straight line, bhai, parallel to x-axis, okay, and it cuts the graph at only one place. Bacha, like this. How many intersection बच्चा? Only one intersection. That will be a 1-1 function. Whenever you take a line, this, very important, parallel to x-axis, then what happens? The graph, the line that you've taken parallel, cuts the graph of the function at only one point. Remember, at only one point. Then I will call that function to be, okay, 1-1. क्या कहेंगे? What will call this? 1-1. And in any other cases, many one. In any other cases, many one. Can we take some examples, sir? Let's see. Okay, we can take some examples. So we took linear function. Okay, I hope. Okay, before going to that, let's take some examples. Linear we took. Let's take some exponential or logarithmic function. If I draw a line parallel to this, cuts at one point. So 1-1. This is what? Logarithmic function for a between 0 and 1. Okay. Okay. Or yeah. So this is for logs. What about exponential function, bacha? It looks like this. Okay. Other part of this line is also there. I hope you know that. This is also the exponential function. Okay. So any of these you take. Okay, but let's not confuse it. We'll take one at a time. Any graph for log. Okay, and this is for exponential. Y equal to ex का graph है ये. Y equal to ex. How many points? If you draw a line parallel to it, draw it. How many points of intersection? Only one, sir. Only one, sir. Again, 1-1 function. Okay. Linear also we have seen. What about this, sir? We have seen this graph in grade 10, in grade 11 also. Conic section. How many intersection, bacha? Check. Tell me. 1 and 2, sir. 1 and 2, sir. So, many one. What is this? Many one. Whereas these are 1-1. I hope this is clear. If you know the graph, draw it and get the result. And take your answer correct, get 1 marks. Right? Feels like bonus if you know the graph. Chaliye. That's why graphs are important. Now, other kind. 1-1, many one is done. What other type of function are there? So, onto. What is the other type of function? Onto. As I said, name is important. So, surjective also. The name of the function other than onto is surjective function. Okay. When this will be true? When this will be true? For this, no. For onto function, don't look at the domain part. Only you worry about the codomain part. Only worry about codomain part. This part. What is codomain? My B, right? My B. Now you look at the codomain. Look at the codomain. If every element in codomain has some image, doesn't matter it has common image or not, doesn't matter. Okay. If it has some pre-image. So you know that if I'm writing A to B, right? I'm going to use this word. So let's define it for you. So for element X here and Y here. So for X, what do we call Y as? Image. What we call, bacha? We call it as image. And what we call X as? क्या कहते हैं? Pre-image. What we call this as? Pre-image. I'll repeat, please listen to me. For X, Y is called as image, and for Y, X is called as pre-image. Clear, na? Okay. Now, so doesn't matter whether it has common image or not, but make sure that every element in B has some pre-images. Means some element will be connected in the domain part. So check for P something is there, for Q something is there, for R something is there, for P I have A, for Q I have B and D, for R I have C. Correct? So whenever this is true, so basically if I am writing, let's say I have to write ordered pairs. We learned 9 relations, ordered pairs, bacha. Let me write all the ordered pairs. What is now ordered pair? Sir, first we'll take element from A and then we'll take element from B. Wherever the relation is existing, it's called ordered pair. Okay. If I'm writing it, how will I write? So A, comma P. Okay. A, comma P. Then how will I write? B, comma Q. Okay. B, comma Q. And what will I write? C, comma R. C, comma R. What about last one? D, comma Q. Last one is also D, comma Q. Okay, sir. So we have 4 ordered pairs. C, comma R. This is C, comma R. So we have 4 ordered pairs here, A comma P, B comma Q, C comma R and D comma Q. So for these ordered pairs, if you check here very carefully, none of these are missing. So if you check here, what is the range? What is the range here? The range is P, Q, R. It's Q, so we don't have to repeat. So the range is nothing but, the range is P, Q and R. And what's the codomain? What's the codomain? Please check. Codomain is B, and what is that? Again, P, Q, R. Very beautiful thing coming here. Whenever range and codomain becomes equal, that is called as onto function. That is called as onto function. So we wrote all this thing. First element is called as domain, second element of all the ordered pair is called as range. I wrote the range, and that is fortunately for us equal to the codomain. Whenever that is true, bacha, it is range is equal to codomain. The function is onto. Definition, let's read once. Function A to B, A is domain, B is codomain, called onto or surjective only if each element of B is the image of some element of A. Okay, some element of E means nothing has to be, the B elements in B should not feel left out. Simple thing, element in B should not feel left out. I hope this is simple and I explained you. चलिए आगे बढ़ते हैं. Into just opposite means at least one element in B should feel left out. What did we say in onto? What did we say in onto? कि none of the element in B should feel left out. But in this, a minimum of one element should feel left out. Okay? At least one element should exist, bacha, which is not having any pre-image, which is not having any pre-image, right? For Q, what is the pre-image? For P, the pre-image is A. For R, we have two pre-images, B and C. But for Q, no pre-image, right? For Q, we have what bhaiya? We have no pre-image. सही बात है? Clear, right? For Q, there is no pre-image. That's why this function is into. Definition done. Shall we move on, please? Okay. Sir, what is the good thing about this slide? No other name. Onto had surjective, into has no other name. So no one less thing to remember, right? One less thing to remember. चलिए. Good for me also. Our methods to check. अब कैसे check करेंगे? How will we check whether a function given is? So we learned the methods to check how it is. 1, 1 and onto. Right? Sorry, 1, 1 and many 1. Forgive me. 1, 1 and many 1. For 1, 1, many 1. From definition we did x1 equal to x2. Then fx1 equals to fx2. या फिर x1 not equal to x2. Then fx1 not equal to fx2. The function is 1, 1. Or the graphical method. Draw the graph of the function. Draw a line parallel to x-axis. Cuts at one point. The graph of the function is giving me the function, the intersection of the graph of the function is 1, so the graph is giving me 1, 1 function, if not many 1 in both the cases. But what about onto and into? What about onto and into? When can we say the given function on A to B is onto? Yeah, into. Onto and into. What we learned in onto? If the range and codomain are equal, then it is onto. We have two methods here again. Find the range of the function f. If range of the function and codomain equal, the function is onto. In any other case, it is into. I'll repeat. If the function's range and codomain are equal, then means that they are onto. If not, all the cases into. All the cases into. Means if they are equal, surjective. If not, into, sir. Okay. चलिए, let's read the second method. Let f be again A to B. Okay, consider y. Take any value of y. From where will you take? So if you know the codomain, bacha, you can pick any value, no, from y. Okay, this is my y. Y belonging from where? From the codomain. So take any y value from here. Take any y value. Basically, any image of value. Any image value take from B. Okay, and for that you solve this equation. Okay, let's say y equal to fx is there, no? The function can be linear also. Let's say I take this 2 equals to x minus 1. Okay, Then what are you going to do? I'll bring this one here to 2 plus 1. This is just for example, okay? So I'm getting x as 3. Just example, no mistake of some value of y from the image. I'm asking you to assume that 2 is part of codomain. Alright. Then find x, find the x. So obtain x in terms of y. Means solve the x value in terms of y. We got it as 3. Okay. Now, for every y equal to b, okay, if x does not belong to a, then f is not on 2. Means if this x is present in b, let's say the 3 is present here, 3 is present here, but if I have to write range, okay, write range, and x is not in the range, x is not in the range, sorry, yeah, not range, okay, set A, the domain. If x, because x we are looking, no, 3 cannot be, pardon me, 2 will be here, no, because we are taking 2 as my y value. Check here, bacha, I have taken 2 as my y value, so 2 will be here, no. So for this 2, if x here, if x is not, 3 is not in the domain, then we will say it is not on 2, it is not on 2, and it is into, alright. But if for y belongs to b, this corresponding x belongs to a is there, then f is on 2, okay, f is on 2. First method, range and codomain equal. Our second method, take a value of y from the codomain, solve it. If x is there, then on 2, x is not there, into, chaliye. Moving on. Understood? I think you guys understood, no? On to surjective, important, okay, because this will make us to understand bijections, okay. So on to is very important, but into is also important because it's just reverse of on to, just other part of on to. If something is there like missing, left alone, that will be into, left alone, okay. Think about, I took some value of y from here, and for that nothing is present here, means the x that I got, okay. Second method, if I have to explain again, the x that I got from here, some pre-image I will get, na. If that is not in A, bacha, if that is not in A, means x does not belong to A, it means this is left idle or alone, okay. If that is alone, it means it is into, that's what I was saying. I hope this is clear. If for q I find the x value or the pre-image value, and that is not present in the domain, it means left alone means into, okay. Chaliye. Okay, look, my thing is, no, my intentions are very clear. If I am coming here, if you are watching this video, then your doubt should be cleared, because you have other things to study, you have other places also to study. If you are after giving time at that places, if you're coming here, then it should be helpful, right? So I will put little bit extra effort. My videos might be longer, but I'll make sure that you are here, then you are cleared with your doubts of that particular concept, correct? Chaliye, आगे बढ़ते हैं. Let's proceed, sir. Now bijection. I was talking about this. What is bijection? Remember this word. This combination. We learned na both of these right now. The combination we will know. 1, 1 and on 2. Whenever a function satisfied both the condition. Sir, confusing again. 1, 1 means what? Think from the graph. Sir, if I draw a graph, only one intersection. 1, 1. Okay. Okay. Don't worry about definition. Draw a graph, only one intersection, 1, 1, sir. Okay, sir. Other method, you can go back and see again. What about onto? Nothing should be left, sir. In the codomain, nothing should be left. Perfect. So 1, 1 onto will be for every element, for every element in the domain, there exists a unique element in codomain. Also, none of these elements are feeling left out. Everything is connected with some pre-image. So if you see here, domain and codomain are equal. Range and codomain are equal, and the uniqueness is also there. For A I have Q, for B I have P. So if I write the ordered pair, bacha, how will that look like? For A I have Q, for A I have Q, for B I have P, for C I have S, right? and for D I have R. So all these X values, all these domain values are having unique range value or unique images. Image of A is Q, image of B is P, C is S, D is R. Only then we can say the function is of bijective kind. The function is bijective kind. Okay sir, okay sir. Chaliye, if you have to read this definition, chaliye, if distinct element of A have distinct images in B, distinct element means different element in A has different images in B, only then we will call 1 so that is like okay. And if every B has some image or pre-image, okay, every B is the image of some element of A, okay, every element in B is the image of some element of A. So this is the onto part definition. This is for onto and this is for 1. Clear sir? Moving on. चलिए आगे बढ़ते हैं. Okay, आगे बढ़ते हैं. Now this questions are there. Okay, number of relations questions, less questions are asked, but again can be useful. But on number of functions questions are asked. Okay, I've taken such questions in our practice session, so this will be important, bacha. So let me revise, let me recall everything for you. Okay, so number of functions. So what does this represent, sir? The function on A to B means A is my domain, B is my codomain. Okay, mod of A means number of elements in A is what? M, and number of elements in B is N. Chaliye, okay, the number of functions is N to M. The number of function is N to M. From A to B, if the function is defined, the number of functions given by N to M. Okay sir, the number of 1 function, only injective part we are talking about, only injective part is given by NPN. What is NPN, sir? NPN is permutation, right? How will you write this? N factorial upon N minus M factorial, but only if N is greater than M. N is greater than M. Okay, so only for 1 function, this is the expression that we have, NPN. Okay, NPM. Sorry. NPM and N is greater than M. Okay, the number of onto function, surjective. This is for injective, this is for surjective. Okay, what is it? Summation of, why this part? Why this part, sir? To know the sign. -1 to even number will become positive, -1 to odd number will be negative, -1 to odd number will be negative. Okay, NCR, this is NCR times R power M. I hope you can see this. So combination is there, NCR R power M, provided N is less than M, provided N is less than M. This is the condition, required condition for surjective or onto functions. Number of surjective or onto functions. What about number of bijections? Again, this is true only if M is equal to N. What is the number of bijection? N factorial. What is it equal to? N factorial bhai. If M and N are equal, then we will have bijection, and that is equal to N factorial, sir. Okay, so number of function, quickly we have recalled it. Let's go back and solve some problems, sir. Very important part of my sessions. Look, theory we can do, obviously important to understand the concept, but if you do not practice the questions on them, then how will you know whether you are ready or not for your mocks or for your examination? So what I do is quickly we will learn the concepts, we'll revise everything, all the things which is important, some extra things also, and then come back and solve questions on every concept in the same session, right? Every question in the same session we will solve, sir. Okay sir, let's do the first question, sir. What is the question saying? Let's read. Let R, a relation, a function. Okay, a relation R is given. Why relation, sir? I read this part. They have written here. Why relation? Because they have written a relation, nothing extra. Okay, a relation R is given as 1 3 4 2 2 4 2 3 3 1 on the set A. Means for set A I have relation written like this. Now whether this relation is a function or not, a reflexive relation or not, symmetric or not, transitive or not, we have to pick our, which is the correct option. Okay, so let's check. कैसे करेंगे? R equal to 1 3. So for function, can it be a function, बच्चा? Check here. Can it be a function? For it to be function, trouble here. Check the trouble here. What's written? 2 4 and 2, 3. So if you see that from the definition of function, no, uniqueness should be there. From 2, for 2 value, you are having 4 and 3. You are having 4 and 3. So clearly not a function. So option A though is wrong. Option A is wrong. Okay. Next, reflexive. Is it reflexive? 1, 1 should be there. 2, 2 should be there. 3, 3 should be there. No. Reflexive is not true, because for a relation, for a set given as A equals to, okay, let me rewrite it. For a set given A as, what is it? 1, 2, 3, 4. 1, 2, 3, 4. This is my given set, right? This is my given set, right? So what is my reflexive relation going to be? 1, 1, 2, 2, 3, 3 भी होना चाहिए, and 4, 4, and then other things can also come, no problem. 1, 1, 2, 2, 3, 3, 4, 4. But they are not here, no? 1, 1, 2, 2, 3, 3, 4, no, not there. So I cannot take this to be reflexive also. What about symmetric? Sir, 1, 3 is there, then 3, 1 is there, so good. 4, 2 is there, but 2, 4 is also there. So again symmetric. 2, 3 is there. 2, 3 to hai, but 3, 2 is not there, sir. 3, 2 is not there, sir. 2, 3 is there, but 3, 2 is not there. So not symmetric. Array, this is saying not symmetric, though this option is correct. Transitive. Okay, no need to check only. Option C not symmetric, we are getting it. Option C is right. Single correct option is there. Option C is right. Okay, chaliye. Why to waste time going forward and checking for transitive? It'll take time, right? You have to check for combination of A, B, C. Not transitive. It cannot be transitive, no, because 2, 3 is present here in the relation R, but 3, 2 is not present. If 3, 2 is not present means it cannot be symmetric. So if 2, 3 is there, then this has to be there. Not there means not symmetric. Not symmetric. Answer is C. Answer is C. I hope this is clear. Answer is C. चलिए आगे बढ़ते हैं. Okay, sir. Second problem. Let F be R to R. Okay. R to R. What is R to R, sir? Relation? No, bacha. R means real number. R means real number. R means real number. It means both domain and codomain are of real numbers. Function is given as x plus mod x, sir. X plus mod x, sir. Okay. चलिए. fx is option choose करना है. We have to choose the correct option. Okay. Let's write the fx first. fx is equal to x plus mod x. X plus mod x. Now real numbers. What is x? X is real number. So I will not know how to break this right now. How will I do it? If I take x positive. X positive ले लेते हैं. X positive. Okay. What will happen if I take it as positive or equal to 0 also I can take. If I take equal to 0, then 0 plus 0 will be 0 only, so no problem. So if I take x positive or equal to 0, then what will this be? Fx will be opening with a positive number will remain. Positive number only, and this will be what? This will be x, this will be x. Then I will get this as 2x. Get this as 2x, okay. What about x less than 0? Not equal to. I've already taken the equal to part now, so just less than 0. आगे बढ़ लेते हैं. What will happen to function? Function will be negative number is x, so like this, and this will be x minus x. The mod will open with negative. When x is 0, the mod will open with negative. I hope you understand this part. Lot of people have this confusion. Sir, you said mod of x means always positive, sir. You means whenever you say, sir, mod x means always a positive number. Very good. Okay. Then why you are saying that mod of x will be when x is negative? Why is mod x minus x, sir? Why is mod x minus x, sir? You said x, mod x means always positive. Then why when x is negative, we are taking it as minus x? Because so if let's say I take an example, let's say x is negative, I take a negative number. What is it? I can take minus 2. Okay. A negative number, let me take. Some people will have this doubt, not all of us, but good to learn. X equals to minus 2. X equals to minus 2. Is it less than 0? Yes, sir, it is less than 0. So, if I put here minus 2, what will the answer be? The answer will be what? Positive 2. The answer is positive 2. Why, sir? Because mod gives us positive. Then why have written here minus x, sir? Because to make it positive, what mod is actually doing? To make minus 2 positive, what the mod is actually doing, it is taking a minus sign over here. So minus and minus becomes plus. Minus and minus becomes plus. So basically what I'm trying to say is, this was my x and this is minus x. Okay, so whenever you take x less than 0, mod opens with minus x. If you take x greater than 0, mod will open as plus x. I hope this is clear. Okay, so to make the minus 2 positive, the mod opened with a sign negative. Okay sir, chaliye. So then this will become x minus x. What is the answer? 0. The answer is 0. So fx is equal to 0. Very important to know this part. This is my fx, 2x. Okay, let me summarize it in the next slide. Okay, why to do it here only. Okay, I'm taking a little bit time here, bacha. I hope you don't mind. Simple question, I can quickly do it and move on, but let's learn little bit good things. This was 2x and this was 0. When was this? When x was greater than equal to 0. And when was this? When x was less than equal to 0. Correct? Less than equal to 0, 0. Greater than equal to 0, 2x. Chaliye. So when less than 0, it's 0. Greater than equal to 0 is 2x. How will the graph look like for this function? How will the graph look like for this function? It'll be something like this. Okay, it's a straight line. Doesn't look like it, sir. Okay, fine. Please bear with my drawing skills. Not that great. I will try to improve as I go on. Again, it's not looking like a straight line, but it is a straight line. Okay, chaliye. And what about the less than part, sir? It'll be here, no? Because when x is equal to 0, sorry, when x is negative, for all these negative x values, what is my function? Y is equal to 0. Y equal to 0 means x-axis. Okay, this is my graph. This is 2x part and this is y equal to 0 part. Chaliye. Now let's read the question. 1, 1 on 2, let's decide. So what is it? If I draw a line parallel to x-axis, means like I can draw a line on x-axis only. I can draw a line on x-axis only, like this. When I do that, how many intersections are there? How many intersections are there with the graph? The graph is the white part. White part is the graph, right? How many intersection? Infinite intersection, no? Infinite intersections, right? What did 1, 1 said? For the graph to be 1, 1, it should have only one intersection. But if I draw the line parallel to x-axis on the x-axis only, if I do that, what happens? It is cutting the x-axis at infinite number of points, which is my part of the graph. White part is my part of the graph. So infinite intersections I'm getting. So what I can say? By not 1, 1. Not 1, 1. What about onto? What about onto? चलिए देख लेते हैं. What's the codomain? What's the codomain? What is my codomain, sir? What is my codomain, sir? The codomain is all real, sir. How, sir? Given here, bacha. Codomain is all real, R. Codomain is all real, R. Okay. Chaliye. So codomain is all real, but what is the range? What is the range? Check here. Only positive value. Is there a negative value in y? Can y be negative? No, sir. Y is all white line, na? Y cannot go below x-axis. This is my x-axis. This is my y-axis. Y is not coming down. So y is not negative. Y is only greater than or equal to 0. Is range and codomain equal? Is range and codomain equal? No, sir. Some values, the negative values in the codomain are left out. The negative values in codomain are left out. It means not onto. It means not onto. Basically, into function. What is it, sir? Into function. Let's check the option. So neither 1, 1, nor onto. Correct option is D, sir. Okay, not 1, 1, not onto. So both of the options are in D. Option D is correct answer. Let's move on to the next part. पढ़ लेंगे. Okay, question number 3. The function f. The function f on R to R. What is the meaning of R to R again? Real to real. Okay. This is something interesting. I hope you guys have some understanding of exponential functions. Okay, chaliye. So, but don't worry. I'll try to simplify as much as possible. Okay, I will simplify it and explain it to you in very, very, very simple steps. Okay. So function is given as 6x plus 6, okay, 6 to the power x plus 6 to the power mod x. Now again we have to figure it out, 1 1 on 2, many 1 whatever it is, but that part will come later. First what is we do? We will break the function into understandable format. Let's make it understandable for common people like me. Sir, I don't understand complex mathematics. I also don't understand complex mathematics. Let's break into simpler things that I understand. Okay. What is this function can be written as? Y equal to 6x plus 6 power mod x. Sir, what? Y? I can write, na? fx as y. fx as y I can write. This you will know. From grade 10 we are doing this. 6 power x and 6 power mod x. Okay, sir. Excellent, sir. Again what we do, if you don't know anything, कर लेते हैं ये वाला काम. X greater than 0. What will happen x greater than 0? Check. बताइए. What will happen to the function at x greater than 0? The function will be y equal to 6 power x and mod will open with, don't ask me please, positive sign, sir. Okay. What about x less than 0? What about x less than 0? Mod will open with what? Minus sign. So then why not writing minus here? Because x is negative. No, I don't have to write a minus x. If I write minus x, it will become positive, right? I'm saying x is negative, so 6x is good. What about mod? Minus x. Okay? Please don't have this confusion. Why not 6 power minus x in the first step, sir? Because x is negative, don't need to write it. Only the mod will open with a negative sign. Okay, sir. Now, to understand one thing, 1 1 on 2. Again, the graphical approach I will take. I will take the graphical approach only. One short understanding, short concept. If I have graph here, remember these two graphs? I did one graph as straight line like this. I said 1 1 because cutting at 1 point. 1 1. Great, sir. What about on 2? I drew a graph like this, bacha. If you remember, I drew a graph like this also. Okay, and I said 2 points intersection. 2 points intersection. Okay, means it is not 1 1. If you see carefully, if I try to write the graph again, let me draw the graph again because I want to draw at point 0. I want to draw at point 0, the origin point. Okay, like this. So this is a many one function because the intersection is at 2 points over here and over here. Now see carefully, at the point of origin, okay, before origin what is happening? The function value is what? Before the origin, the function value means the y value is what? Decreasing, sir. Check here, decreasing. How? If I am moving from the left towards origin like this, I am going like this, what is happening? My y value, it was infinity at some point and coming down to 0. Coming down from infinity, positive infinity to 0. What is happening? It's decreasing, sir. From positive infinity to 0. Decreasing, sir. So as I move towards origin, y value is decreasing. So function's value is decreasing. The function is of decreasing nature. Okay, sir. Before origin, function is decreasing nature. Accepted, sir. What about after origin? At x equal to 0, value was 0. At x equals to 1, value becomes some positive number. If I keep moving towards right of the x 0 origin point, what will happen to x value? At some point it will go to infinity, sir. So basically on the right of the x-axis or the origin, not x-axis, y-axis or the origin, the function is increasing in nature. So you can see whenever in the given domain the function has dual nature, increasing and decreasing, the function will have more than one intersection. Okay, but whenever the function is strictly increasing, so see, I move from left to right, what happens to y? Over here, let's take these 2 points. Let's say this was how much? 0 comma minus 4. What is this? This point was what? Not 0. I want to take these points. Okay, forgive me. Look at this, just bear with me. It's a concept, we're going to use it in the question. So this, let's say this is minus 5 comma minus 4. Okay, this point represents, let's say, minus 2 comma minus 2. Okay, and what about this point? This point, let's say, represents 3 comma 4. So look at the x values, minus 4 to minus 2. X is increasing, correct na? Minus 5 to not minus 4, minus 5. Let me rewrite it again. I will erase all of this part only for explanation, not part of the solution. If I'm moving from minus 5 to minus 2, from here to here, moving here to here, what is happening? My y value is increasing, minus 4 to minus 2, minus 4 to minus 2. Same way, I'm going from minus 2 to 3, again x is increasing. What happened to y value? Minus 2 to minus 2 to 4. Y is increasing, means as I increase the value of x, y is also increasing. There's no dual nature. Single nature means increasing function. It can be decreasing also, not a problem. Either of it, either increasing or decreasing, but it has to be single nature. Whenever that is strictly increasing, strictly decreasing, the function is 1, 1. Here, dual nature, the function is many 1 or not 1, 1, not 1, 1. If you need to take a screenshot, take it. I'll erase this part, okay? I'll erase this part. Chaliye. Now I will use for this particular question. The concept will be used for this particular question. The function is what? 2 into 6x, 2 into 6x and 6x plus 6 power minus x. Okay, chaliye. Okay, so y equal to 2 into 6 power x. This is when x greater than 0, and it is also equal to what? 6 power x plus 6 power minus x when x is less than 0. Let's quickly check it. Correct, sir. Okay. Now to know whether the function is increasing or decreasing, what happens? We have to do the derivative. First, a derivative we can do. What do we have to do? First order derivative. Let's find it out. For x greater than 0, bacha, what happens at y dash? Look, the question is taking longer time. Okay. If you know all the concepts, you can solve quickly in 1 minute or 2 minutes or 3 minutes. Okay. Some questions will take time. No, because not all the questions will be of same kind. Few questions will be very, very easy. It will be solved in few seconds, 10-15 seconds. You look at it and solved. But some questions will be difficult. One thing, we cannot leave any question, right? This is a very good question. It uses all the concepts, so it will be time taking. And I am taking more time because I want to explain all the concepts involved in this question for you, so that if you are solving the question, you don't have to make this much of effort. Okay, chaliye. So x greater than 0, y dash, what will happen to y dash, bacha? Y dash will be, so basically differentiation of this. So 2 is a constant, 2 will be outside, 2 will be outside. Correct, right? We can take the constant common, no? Or keep it as outside. So y equal to 2 will remain this, and differentiation of this will be 6 power x only and ln 6. Okay, so I can write this as 2 times of ln 6 power x. Great. Okay, what about this part? This is for x greater than 0. Now check here. 2 is a positive number, ln 6 is again a positive number, and 6 power x, if you look at the graph exponent, it is positive number. Okay, okay, a positive number means entirely what happened here is, I don't need that part here. Entirely y dash is greater than 0. It's increasing. What is it? It is increasing function. What is increasing? Fx is increasing. Okay, y is increasing when x is greater than 0. First conclusion is made, sir. Y is increasing when x is greater than 0. Second part, what happens when x is less than 0? What happens when x is less than 0? Take the differentiation, please. Take the differentiation. Y less than 0. Karenge? So what will this be? ln 6, again 6 power x for this part. What about second part? There will be a minus sign because 6 power minus x is there. ln 6 power minus x. Please take it common. 6 power x. Please cross check the differentiation. If I made a mistake, correct it. I'm trying not to make any mistake, but if I make, I'm also a human being. Okay, sometime a teacher can also make mistakes, right? Okay, chaliye. This is it. ln 6 power x minus 6 power minus x. When this happens, now look at this. Look at this very carefully. So this is a positive number. Why, sir? ln 6 is a positive number. It's a constant. Now 6 power x. When x is less than 0, how will this look like? Exponential function. Reverse, na? Reverse, right? Means for x, it will be, this part 6 power x will be less than 6 power minus x. So this will be 6 power x will be less than 6 power minus x, because graph is decreasing in nature. Okay, we can say that this value will be what? This value will be, this value 6 power x minus 6 power minus x will be less than 0. Less than 0. Because 6 power x is less than 6 power minus x. For that reason, the difference is also less than 0. This is smaller, this is bigger. Difference is negative. If the difference is negative means, I am trying to say is y dash is less than 0. When, sir? When x is less than 0. So what we got here? Y dash is less than 0 when x is less than 0. When that is there, it means that the function is decreasing, sir. The function is decreasing. Okay. So if you look at the graph of this function, it will also look like this. It will actually look like this. After this is x equal to 0 point, it will be increasing in nature somehow. So it will be like this. Okay. And before this, it will be decreasing in nature. So like this. Means as you move forward, it is decreasing. As you before like for the negative value, if you increase the x, it is decreasing in nature. You can see the trend. And as you move after the origin, increasing in nature. So if you draw a line parallel to x-axis, how many intersections, bacha? 2 intersections, sir. Sir, you did all of this to get 2 intersections? Yes. I can solve this question using numbers also, but not my way. For us, we will use graphs. Simple and no point of mistakes, because I will not be able to take or think of all the numbers at once. But if I look at the graph, I will be very sure of my answer and I can go ahead peacefully saying that I got 1 marks here. Okay, chaliye. So 2 intersection means, sir, if you did all of this, then okay. Not 1 1, sir. Not 1 1. 2 intersection na, sir. So not 1 1. Okay, bacha. What about onto? Sir, if you look at this, exponential function is always greater than 0. Okay, both of this, all, whether it is negative or positive. So you will say, sir, you got this as negative, sir. But I'm not talking about the y dash. This is differentiation, first order derivative. I'm talking about the function, bacha. I'm talking about the function. The y value will always will be greater than 0 or equal to 0. Okay, so it will never be what? It will never be less than 0. It will never be less than 0. Now check here. Positive and both, this is also positive. So if the graph is always positive, it means what is my range? What is my range? Range is 0 to infinity. Okay, 0 to infinity. Range is always positive. If you are getting confused over here, just write positive. Only positive number. What about my codomain? What about my codomain, sir? Look at the question, sir. Codomain is R, sir. All real numbers. All real numbers, sir. All real numbers will have negative numbers in that as well, sir. If it is negative means there will be some numbers in the codomain which will have no pre-image, sir. It will be left out because range is only positive, sir. Some numbers are left out means not onto, sir. Not onto, sir. So not 1 1 and not onto. Check the question. D. Not 1 1 means many 1. Not 1 1 means many 1 and not onto means into. Not onto means into. Option is D, sir. What did I got? I got not 1 1 and not onto. You will say, sir, you got not on and onto, you are writing many 1. Because not 1 1 means many 1 and not onto means into. Answer is many 1 into. Option D is correct answer. Good question. Took some time, but we understood everything. Okay, let's move on, sir. Okay, sir. Okay, I hope this was clear. Now, again, very simple question. Let's see. We'll solve this question in 30 seconds. X minus, what is it? After reading the question also, we have to explain the question also, na? So function is written on natural number. So this is, what's my domain, bacha? Domain is natural number. What's my codomain, bacha? Codomain is also natural number. Okay, great, sir. Function is written as x minus 1 power x. Okay, sorry. Okay, great. If x is even, whenever you see minus 1 power something, no, understand that they'll be using even and odd function, because minus 1 makes what? Positive or negative, and it will be positive or negative when it is even or odd. Even means what will happen if it is x is even? The function will become fx will be x minus, it will open with plus sign, so x minus 1. What about fx is x minus 1 power x and x is odd? x is odd bhai. X is odd means the function will become x minus and minus 1, because odd number minus 1 will be minus 1 only, becomes x plus 1. What are these functions bacha? They are linear functions, sir. They are linear function, means line will be straight here. Whatever the line is, straight here. Whatever the line is, okay. So line is straight. Strictly 1 1 on 2. Strictly 1 1 on 2. Straight line means all real number. So domain and range remains same. Natural number we are looking, no, only natural number. So we will not go to negative side. We will not go on the negative side. Okay. Doesn't matter. We will not take the graph like this. But basically the point will be what? The point will be, why I am using the graph? Because it's said here. Because it's said here only natural number. Okay. So only for natural number we will take, for positive number only. But whatever it is, it will be a straight line, na? Both of the graphs are a straight line, bhai. Straight line means strictly 1 1 on 2. Why? Increasing. Okay. 1 1 on 2. Option C tick mari. Come on. Option C 1 1 on 2. Moving on. Easy question. Fifth one. Ha ha ha. Trigonometry is back, sir. Okay, sir. Let's see. 1 1 is given. It's given 1 1. Okay. Is given 1 1. The function is written here. The function is like this, and it's saying that it is 1 1. But they're asking where it is 1 1. The asking is where it is 1 1. Whether in option A, option B, option C, option D. So answer written here C. You can say na C, but how? Let's see. Let's see. Let's see. I can write function fx as कैसे करेंगे? √3 sin 2x minus cos 2x plus 4, sir. 4 is okay, sir. 4 is a positive number, so not a problem there. What about this? √3 sin 2x cos 2x. I can do it like this also, na sir. Multiply 2 कर लेंगे. Multiply and divide. Okay. Let's take the division inside. Let's take the division inside. If I do that, it will become what? √3 by 2 sin 2x minus 1 by 2 cos 2x, sir. Cos 2x, sir. Only for this part. And plus 4 will be outside. Sir, why did you do that? Why did you do that? Check here. 2 into 2, 1. 2 into 2, 1. 2 in numerator, 2 in denominator. Cancels each other. 1. Nothing is there. Only 1 is there. 2 into minus 1 by 2. Just minus 1. Nothing is there. Only minus sign is there. So that's why I took 2 in the denominator here and here. What difference does it make, sir? Let's see, sir. I'll keep 2 as it is. √3 by 2 can be written as, this is sine for cos. Let's write for cos. Why, sir? Formula sin A cos B. Yes, yes, yes. So write this as sin 2x. Sin 2x. And what about √3 by 2? Is it cos of pi by 6? Cos of pi by 6, is it right? Cos pi by 6 is √3 by 2, correct? Okay, moving on. Moving on. Again, cos 2x will come. Cos 2x. What about 1 by 2? Sin pi by 6, right? Sin pi by, wait. Pi by 3. Okay. I'm doing sin 2x minus cos 2x. Okay. √3 by 2 will be correct. Pi by 6, sir. Got confused, sir. Sorry, sir. Table याद करना पड़ेगा, right? Have to remember the table. So cos pi by 6 minus sin pi by 6. Okay, because sin pi by 6 is 1 by 2 and cos pi by 6 is √3 by 2. Okay, sir. So I have used this √3 by 2 as cos pi by 6 and 1 by 2 as sin pi by 6. Sorry, sir, for taking your 1 minute extra. Okay, will not happen again. Let's move on, sir. Okay, sir. How will this look like, bacha? Check here. Check here. Sin A cos B cos A sin B. Sin A cos B cos A sin B. Sin of A minus B, na sir. Sin of A minus B, sir. No problem. Sin of A minus B, sir. Simple, simple, simple. Very simple. What is A minus B in this case? 2x minus pi by 6. 2x minus pi by 6, isn't it? 2x minus pi by 6, sir. Why, sir? Why 2x minus pi by 6? Because 2x is my a and pi by 6 is my b. I can write this as 2 times of sine of 2x minus pi by 6 plus 4. Okay, sir. Now 2 is a constant multiplied, so it will become what you call transformation is there. 4 is also transformation. Okay, transformation for the function. So that will not matter in case of this, basically moving the graph up or expanding or contracting it. But the graph's nature in the interval is given as 1 1. When is the sine 1 1? Means they're asking where is it 1 1, but when is the sine 1 1? Is sine always 1 1? Look at the graph of sine function. Look at the graph of sine function. Is sine always 1 1? So not a straight line. Looks very pathetic. Let's draw it again. Okay, sir. Okay, sir. Try to something like this. Okay. So sine graph, if I have to look sine x, how will this look like? Like this, sir. Okay. Is it always 1 1? No, sir. 1 intersection, 2 intersection, 3 intersection, 4 intersection, sir. So not always 1 1. Okay. Okay. What if I transform this? What if I redraw it like this? How, sir? Array, at this point the graph is here, and at this point the graph is here. Same graph, no? Y equal to sine x, but in restricted domain. In restricted domain. And what is that, sir? This point is called as minus 90 or minus pi by 2. This is called as plus 90 or plus pi by 2. So in the domain minus pi by 2 to pi by 2, the sign will be what, sir? The sign will be 1 1, sir. How, sir? How 1 1? Draw a line somewhere here or here, any line you draw, cutting the graph at only one point. So it is 1 1. Okay, sir. They said na 1 1. Find the interval where it is 1 1. Not sine x. This function should be 1 1. So if 2 and 4 are just transformations, right? So if this inside part is 1 1, it means the entire function fx will be 1 1. 2 and 4 are transformations. If this inner part sine is 1 1, then entire part will be 1 1, and we know the sine is 1 1 in minus pi by 2 to pi by 2. Therefore I can write this, that minus pi by 2 should be like this. Okay, should be like this. And what is the value? 2x minus pi by 6. 2x minus pi by 6, and what here? Pi by 2. Pi by 2. I written as pi by 6. Forgive me. Pi by 2. How, sir? How, sir? How, sir? How, sir? Because for this function to be 1 1, the sign has to lie in between what value? Only this value, because only here the sine function is 1 1. So whatever is this value, this has to satisfy this equation for the angles, right? Minus pi by 2 is pi by 2 what? Domain or the angle value. So whatever, if the function, this function has to be 1 1, then this function's value of the angle for sine has to satisfy the domain where the function is 1 1, minus pi by 2 to pi by 2. Let's find the value of x from here. So bring the pi by 6 on this side and on this side, because we are solving both the inequalities at the same time. Okay, so minus pi by 2 plus pi by 6 less than equal to 2x less than equal to pi by 2 plus pi by 6. कर लेंगे. Simplify this. What is LCM? 6 is the LCM, sir. Minus 3 pi plus pi less than equal to 2x less than equal to, LCM is 6, sir. This is 3 pi, sir, plus pi. Okay, sir. Bring it here. Minus 2 pi by 6 less than equal to 2x less than equal to 4 pi by 6, sir. 4 pi by 6, sir. I wrote it as 4x, sir. Sorry, sir. 4 pi by 6. 4 pi by 6. Great, sir. Bring the 2 here, sir. Minus 2 pi by 6 into 2 less than equal to x less than equal to 4 pi by 6 into 2, sir. Cancel something, sir. Something you cancel. Okay, sir. 2 and 2 goes out. And 4 is there in numerator and 12 is there. I can cancel 4 with this thing as 3. Final answer, sir. Minus pi by 6 say less than equal to x less than equal to pi by 3. So basically x belongs to minus pi by 6 comma pi by 3 है ना. Close because equality is present on both sides. Forgive me please. Equality present on both sides. So answer is minus pi by 6 pi by 3. Minus pi by 6 pi by 3 both included. Answer is what, sir? C. Why I did this? So they said that find the interval where this function given is 1 1. So I simplified this function like this. 2 and 4 are my transformations. I know from the graph that sign is only 1 1 in case of this bacha. I am repeating the same thing, that's why I laughed. So repeating only 1 1 in this domain, minus pi by 2 to pi by 2. This is called as restricted domain. When that is true, means whatever is the value of the angle in this case has to fall in between minus pi by 2 to pi by 2. Simplified, this got the x value as minus pi by 6 to pi by 3. My final answer is option C. Check it out here, sir. Moving on. Come on. Moving on. Let the function f r to r. Okay, sir. Means domain is this bacha and codomain is this bacha. Means both of them are real. चलिए. अरे this is the easiest question ever. आराम से कर लेंगे. After all of this, sir, we will rock this in question, sir. Let's see, sir. नहीं होगा? Let's check it out. क्या है भाई? Question is 2x plus sin x, sir. 2x plus sin x, sir. So difficult. So difficult. I'm scared, sir. कैसे करेंगे, sir? नंबर भी है, sin x भी है. Okay, sir. What did I teach you? Don't forget, don't read about this right now. In this question, figure out 1 1 1 2. Know your techniques, know your understanding. Increasing, decreasing कर लेते हैं, काम हो जाएगा. Let's do increasing, decreasing for this function. How will I do that, sir? Derivative. Find derivative. If derivative is greater than 0, increasing, less than 0, decreasing. If there is a break, then not 1 1. Okay, sir. Derivative of this will be what, bacha? 2x will be just 2. Sin x will be cos x, sir. Cos x, sir. Cos x range. What is the range of cos x? Sir, cos x range is, I don't know, sir. Minus 1 to 1. Minus 1 to 1. If you see the graph of cos x, बना दे, sir, you like the graph too much. Bad influencer, lot of graphs. Okay, so a graph will go like this for cos x. Upper band is plus 1, lower band is minus 1. So the value will not exceed this band minus 1 to plus 1. So whatever value you put here for cos x, I do not know. Any value you put, because x I don't know, so how will I know what is cos x? But whatever you put, minus 1 or plus 1, our boundaries, this 2 will make it positive only, no? 2 minus 1 you take, 1. If this is, let's say, minimum value minus 1, 2 minus 1 is 1, 2 plus 1 is 3. Either case, f dash x positive है ना, sir? F dash x is positive, sir. So it is what, sir? Strictly increasing, sir. What is it? Strictly increasing function. If that is true, mark the tick. 1 1 onto. Strictly increasing, 1 1 onto, done, sir. 1 1 onto, done, sir. Let's move on, sir. हो गया? Easy question, right? Strictly increasing, no? Strictly increasing. Great. Okay. Okay. Okay, this question. चलिए कर लेते हैं. Let's read the question again. This is okay. R to R. Function is given like this, sir. Have I taken? No, sir. यहीं पे solve करना पड़ेगा. I have to solve here only, sir. No problem, sir. We will solve x square plus 1 का power 39 is my y. The function is, I can take the function as y. Don't be worried. I should not be worried if I take it as y. Okay, fx is y, no problem. अच्छा, if I take x as 1, x को 1 ले लें, what is this going to be? 1 square plus 1 power 39. So sir, 1 plus 1 square is 1, 1 plus 1 is 2. So 2 power 39. My y value is 2 power 39. Take x as minus 1, बच्चा. कर लेते हैं. Minus 1, what will this be? Again, minus 1 का square plus 1 power 39, sir. Minus 1 square is again 1, sir. 1 plus 1 will be same thing. 2 power 39. अरे for same x value, sorry, for different x value, y is same. You must have forgotten this since I'm doing graph for so long. This part, x1 not equal to x2 if it's given, x1 not equal to x2 is given, then fx1 cannot be equal to fx2 when it is 1 1, when it is 1 1. But see here, x1 is equal to 1 and x2 is equal to minus 1. They are not equal, but y values are equal. 2 power 39, 2 power 39 means not 1 1, not 1 1. So what is it? Many 1. What is it? Many 1. It is not 1 1. So first part is done. What about onto? What about onto? Means we'll check what? Onto means domain and codomain and range we will check. चलिए कर लेते हैं. Codomain and range means the values of y will matter here. Find the value of y. Let's find the value of x first. Okay. Let's find the value of x first. If I do that, what is going to be? X square plus 1 is equal to y to the root of 1 to 39. 39th root will be this. How, sir? Array, if it is power 39 means that side will go. The root will become 39th root, no? Okay, bring 1 there. X square will be y power 1 by 39 minus 1. X will be root of y power 139. Okay, now see this, all real. Okay, but for some values of y, x will be, x has to be always positive, no? X has to be, this has to be always positive. For this reason, for this, check here, check here, check here, check here, check here. देख लेते हैं, फिर से देख लेते हैं. Let's check here. Y power 139 means this value, if you check here this value, this cannot be negative, bachcha. This cannot be negative. I don't think it's visible. Let me write it again. Let me write it again. Let me write it again. Okay? 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 Y power 1 by 39 minus 1. Okay? The inside value cannot be negative. Inside value cannot be negative. Why, sir? Because the root of negative number will be what, sir? Sir, we have learned in a complex number. I can find root of a negative number, but it is given as real, bacha. It is given as real. If you find root of complex number, it will become imaginary. Okay, it will have imaginary part. So this cannot be negative. So there is a restriction on y. So what will happen? What will happen? Codomain will not be equal to range. If that is the case, what we can say? Sir, not onto. Sir, not onto. Which is the option? Not 1 or not onto? Option C. Done. Moving on. Not giving more time to this question. Okay? Not 1 1 because codomain and range are not equal. Question number 8. Set A has 3 elements and set B has 4 elements. Okay, bhai. So, number of elements for set A. For set A के लिए 3 and set B के लिए 4. Number of elements is 3 and 4. 3 and 4. Okay. Find the number of injections. Array, this was permutation question, no? Remember this. N, okay. NPM tha. NPM equals to n factorial upon n minus m factorial, sir. Where n is greater than m, right? Check here. Somewhere here we have done this. Number of functions करे थे. We have done this here. Number of injections, right? Number of injections. Injections means what? 1 1 function, na? 1 1 function. What was it? NPM, n factorial by n minus m factorial when n is greater than or equal to m. Let's go back to our slide. Okay? Okay? Okay. So let's use it. N is 4. N is 4, m is 3. So what will this be? 4 factorial upon 4 minus 3 factorial. 4 factorial is 4 into 3 into 2. This is going to be 1 factorial, which is nothing but 1. So 4 3s are 12 and 2. So 24 by 1, answer is 24. Option is C. Option C. Okay, option C. All right. Okay, sir. Easy question. I said no, the questions can come on this type, number of functions. Even number of relations you can expect, but even if you don't expect it to come, good to know the formulas, good to know the formulas. Which of the following function is 1 1? Array, this is the easiest question, sir. Easiest question, sir. Why, sir? 1 1 means graph process will do. Graph process, what is it? 1 intersection, 1 1 function. Okay. Sin x. By sin x is like this na, right? Okay, so it doesn't look like sin x at all. थोड़ा सा बढ़िया बना दीजिए सर, come on. Okay, 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 let me draw a better graph. Okay, 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 I erased it, sorry, forgive me. So this is my, okay, look at here, domain is not given, domain is not given. If it said only from here to here, then I would have said 1 1, but there is no domain given, so I cannot take C also. Okay, e power x square, if you look at the graph of e power x square, this will come like this something. E power x square, if you see, it comes like this something. So again, if you draw a line, cuts at 2 point, so not there. E bar x, forget about. So you might say, sir, how do I know the graph of e power x square? Forget about that. E power x, you know na. E power x has two type of graphs. One is like this and one is like this. Both the graphs, if you say, this is for e power x only, okay, this is also e power x only, okay, for both the definitions, okay, for both the definitions, okay. Chaliye. So whether you look at this graph or this graph, any graph, you check it out, draw a straight line. How many intersection? One intersection. One intersection means 1 1 graph. Answer is A. Answer is A. Answer is A. Answer is A, sir. Answer is A, sir. I am moving on, sir. Okay. Last question of the day. Arey, I have done this question, but you will not believe it. I have done this question. How, sir? I'll tell you how it is related to the previous question and then conclude the session. Function is given as x plus root of x square. X plus root of x square. Okay, sir. X will remain as it is. Root of x square. Mod x na, sir. Why mod x, sir? Because root of x square, root and square will cancel each other. For any root, we have two possibilities, plus and minus. That will be taken care by mod. Whether it is plus, then plus, negative, then minus. We have solved this question, x plus mod x, right? X plus mod x was coming as neither 1 1 nor 1 2, sir. How? Check it here. X plus mod x wala question kahan gaya? Where is x plus 1, x plus mod x? X plus mod x was this question, right? X plus mod x. X plus mod x. Neither 1 1 nor 1 2. How did we do it? We drew a graph for this. Remember this graph? It is cutting on the x-axis, so many points, so it cannot be 1 1 function, and there is no negative value for this. Even though the graph is defined for real numbers, there is no negative value. It means the codomain and range are not equal. So that's why it is not onto. So if you go to the last page, last question, so it is what? What is it? Not 1 1 and not onto. Not 1 1 and not onto. So none of these. Injective means only 1 1. This means only 1 1. Surjective means onto. And bijective means what? 1 1 onto. 1 1 onto. If you were smart enough, think about it. You can directly pick from the question, not solve anything. Just look at the question and see. It is a single choice correct question. Think about it. Bijective. If it is bijective, okay, then I can take it as injective and surjective. Both. Then how can be all options true at the same time? But okay, it can be just onto also, it can be just 1 1 also. So better to know the graph. What is the graph? This is the graph, sir. Okay, this is the graph. Okay, go back, look at the question, look at the solution and solve it. This is the end of the session, sir. Option D is correct. This is it for the second session. Now for the next part of the relation and function, we will have a mock on the basis of this. Okay, I hope you learnt a lot. Okay, I hope I was able to clear your doubts. I hope I was able to figure out those weaknesses, those jitters, those scary part of relation and function, and I have dealt with. Okay, so great having you all. I am very glad that you are joining me for all these sessions. Keep commenting, keep getting involved with the sessions. Give me more energy to come up with every day with some improved learnings, improved work from my end. Okay, so what did I say for every session? Keep working hard, no rest. Okay, because we are here to score out in our mathematics KCET, and you know that it will require a extreme amount of effort. So always remember, keep working hard, but you need to have a smile on your face. So with the smile, work hard, and I'll see you in the next session. For now, tata and take care.